Hi, good morning, everybody. Today we're going to do section 2, chapter 2. This one deals with the algebra of functions and the difference quotient. If we have time, we'll go on to the next one, next section, section 4, that deals with symmetry, but I doubt if we'll have that much extra time. Okay, when we say the algebra of functions, we're talking about you can add them, you can subtract them, multiply them, and divide them. And they behave the same way they do as numbers or letters when you multiply and divide them, or any of the algebra functions. The only difference is that now we have to worry about the domain of this, because you have two functions. When you combine them, how is that going to change the domain of the new function that's being formed? So we have four basic ones. We'll start off, we have two functions, f of x and g of x. They're defined functions of something. What this says is you can add the two functions together and then take with respect to x, or you can split them up and do the two functions separately and then add up their answers. So for example, for this one, what that means, we can either expand it or keep them together. Take both those functions with respect to 2. So this left side, what that means is we're going to take the f function, which is x plus 2, and then we're going to add to it the x. Let's not make x squared. Let's make it simpler. Let's make it x plus 1. If we combine those two functions together, x plus x is 2x, 2 plus 1 is 3. Now we can take the 2 and put it in place of x. We have 2 times 2 plus 3. 4 plus 3 is 7. Or we could do the two functions separately. If we put in 2 inside this first one, if we have f of 2, that is 2 plus 2 equals 4. And g of 2, and we're seeing x, is 2 plus 1 equals 3. So f of 2 is 4. G of 2 is 3. Add them together, I get 7. You get the same answer. When you combine two functions together, you always combine like terms. That's why I changed it from x squared to x, so we can combine the two x's. The next one we're going to do is f minus g. We do the difference. That expands to f of x minus g of x. So on this side, we take the two functions, x plus 2 minus x plus 1. And we're going to do it at 2. Notice how on this side, I didn't put my g inside parentheses. Here, after the minus sign, I put my g in parentheses. Why? Well, let's see what happens if I didn't put it in parentheses. We have x plus 2 minus x plus 1. If I didn't put it in parentheses, what does it look like? Only the first x gets the negative. But the whole thing, we have to distribute it throughout everywhere. So this is incorrect. And then we have f of 2 minus g of 2. On the left-hand side, get rid of the parentheses. So we have x plus 2. This negative sign goes to both of those equations. So it's negative x, negative 1. F of 2, we know that's 4. G of 2, we know that's 3. On the left-hand side, x minus x cancels. 2 minus 1 is 1. Since there's no more x's, that doesn't matter. And we get the same answer. The third one is multiplication. We can multiply the two functions together first and then put the x in place, or we can find the values and then multiply the two answers. We're still using the same f's and g's. So in this first one, f is x plus 2. G is x plus 1. We're going to do it when x is 2. F of 2 times g of 2. Now, on the left side, we have, well, these are called binomials because they have two terms each. We have to get rid of the parentheses. The way we do it is every term in the first parenthesis has to multiply to every term inside here in the second one. So we do it. X times x is x squared. X times 1 is positive x. That one's finished. 2 times x is 2x. And then 2 times 1 is 2. Whenever you get rid of parentheses, first step is always combine like terms. x plus 2x is 3x. And this is the funny thing I hate about this book is they expect you to do binomial multiplication, the FOIL method, before they introduce it in the next chapter. So bear with them. So now we put, remember, this is my x value. So I put 2 in place of x. 2 squared, 3 times 2, plus 2. 2 squared is 4. 3 times 2 is 6, plus 2. 4 plus 6 is 10, plus 2 is 12. Well, we know that f of 2 is 4. F of g of 2 is 3. So 4 times 3 is 12. So they equal. Any questions yet? All right, the last one we're going to deal with is the quotient, the fraction. We could take the two functions and divide them first before we put the x in, or we could find the two values and then divide the two values afterwards. So we have x plus 2 over x plus 1, or x plus 2 over x plus 1. So f of 2 over g of 2. We're saying that x is equal to 2. Can we simplify anything inside the parentheses? Can anything cancel? And here, I'm glad you said that. You cannot divide if it's an equation on numerator denominator. You can't separate the pieces indiscriminately. For example, let's say we had 3 plus 2 over 3 plus 1. The x's are the same, so we're saying the 3. If you're saying we can cancel the 3's, what would we have on top? How many times does 3 go into 3? 1. So we would have 3 on top, 2 on the bottom. But 3 plus 2 is 5. 3 plus 1 is 4. They're not equal. So that's why you have to treat them as one. Whenever you have a equation on numerator and numerator, always put parentheses around them. So now we plug in the 2. So we have 2 plus 2 over 2 plus 1. Four over 3. Well, up above we had f of 2 is 4, f of g of 2 is 3, so 4/3 equals 4/3, and that's the same thing. Obviously, the right-hand side is faster, but it's not always the best. A lot of times what this is really saying is if you can simplify the equations before you go any further, simplify them. It may decrease the amount of work you have to do. Let me give you some examples here. Example 1. I'm saying that f of x is x plus 1, and g of x is the square root of x plus 3. Find these. A is f plus g. B is f plus g at 6. And C, f plus g at -4. So work those out real quick. Remember, what this tells us is we can choose either method to find the answers. We either try to put them both together and then find the answer, or we can do them separately and then put the answers together. So what this one really says then is x plus 1 plus square root of x plus 3. You can't go any further. That's as far as you can go. Because you can't distribute inside a radical. So since these are all the same operations, it's much easier if we do that. So what is f of 6? Yeah, because in place of x, I put a 6. So this is a 7. And g of 6, in place of x, I put a 6. Square root of 9 is 3. So g of 6 is 3. Add those together, I get 10. This is plus. So we have to find f of -4. Anywhere I see an x, I put a -4. -4 plus 1. Since 4 is bigger, the answer is negative. 4 minus 1 is 3. So it's -3. G of -4. So anywhere I see an x, I put a -4. Answer is negative. 4 minus 3 is 1. What's the square root of -1? Well, because remember, whatever, like square root of 9 is 3 because 3 times 3 equals 9. What times what gives you a negative number? Nothing. -1 times -1 is +1. +1 times. So this one means that you have no real solution. How do we know that how are you supposed to know that this doesn't have an answer? On the table, the library of functions, Library of functions, we have one of our squares has this in it. What's the graph of the square root of x? Off your library of functions table. What's the graph of square root of x? Where does it start? Where? No. At the origin. Because if you put 0 in there, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. So the graph looks like this. The domain of this function is 0 to infinity. We cannot have a negative inside there. We cannot have a negative inside there. So once you see that, then you know it's no solution. Please, please, please memorize that library of functions chart. It's going to make it much easier for you at the end of this chapter. When we do transformations, you're going to have to know where to start before you start graphing your equations. Okay, here's example 2. F of x equals x squared minus 4. And g of x is x plus 2. For A, I want you to find these. The domain of F, find f of g of x, f minus g of x, f times g, and f divided by g of x. That's just part A. Let's first work these out. Actually, the first one, let's make it easier for us. We're going to do them both, actually. We're gonna find all these, but our first one, I want you to tell me what the domains are of these. So work these out, and then tell me the domains. So this first one says add the two functions together. We got x squared minus 4 plus x plus 2. Combine like terms, so we have x squared plus x. Negative 4 plus 2 is negative 2. We'll stop there for right now for that one. We'll just work them out, and then we'll talk about the domains. The second one, we have x squared minus 4. This is the minus function. So anything behind the minus sign goes in parentheses. We have x squared minus 4. This negative sign distributes through there. So it becomes a negative x and a negative 2. Combine like terms. X squared minus x, negative 4, negative 2 is negative 6. Next one, we have x squared minus 4 times x plus 2. And now we have to what's evidently called FOIL technique. Both of these in the first parenthesis have to multiply both of those. So x squared times x is x cubed. Positive times positive is positive. X squared times 2 is 2x squared. That finishes that one. Negative times positive is negative. 4 times x is 4x. Negative times positive is negative. 4 times 2 is 8. And there's that one. We can't combine anything else. We're done. And the last one, we have x squared minus 4 over x plus 2. Anything cancel? Not just yet, but again, they put this in the wrong section because on the top, we use this rule. If we have two numbers that are perfect squares, like x squared, that's a perfect square, and 9. 9 is made up of what? 3 times 3, so it's 3 squared. Or 25, which is 5 squared. Is 4 a perfect square? Yeah. So if we have x squared minus, this would be 2 squared, we can break it up into that. It's called factoring, which we'll get to later on in this course, but they threw it in too early. So in our case, what does the top become? It's the first and the last term, first and last, first and last. Only thing different are the signs are different. So for this one here, we had x squared minus 3 squared. It would be x plus 3, x minus 3, because those are the two numbers. So what would ours be on top? Very good. Because 4 is made up of 2 squared. And on the bottom, we have x plus 2. Now can anything cancel? The x plus 2's. So if we're going to graph it, that's the equation we're going to graph. A linear equation crosses at -2. Has a slope 1. But fractions have what we call asymptotes. Remember, in a fraction, the bottom number can never equal 0. That's your limitation. That's your restriction on what x can be. So in this case, if bottom is x plus 2, what x can we not use? What x will make the bottom 0? Take your bottom number, set it equal to 0. Subtract 2 from both sides. So x cannot equal -2. That's the only restriction we have on that last equation because we have a fraction, and you cannot have a zero on the bottom. Yeah, this has a lot of rules in there. The rules that you were first taught in elementary school that we haven't used and forgot because calculators. So whenever you have fraction, the first thing you should do is make the bottom equal to 0, and that tells you what x's you cannot use. Anything else is okay, except you can't have the bottom 0. So let's look at the domain. When we look at the domains, when you want to find the domain of a composite function, first find the domains of each function. The domain of the resulting function is that of the smallest domain of the functions. What does all that stuff mean? When you want to find the domain of a composite function, that's f plus x, f minus x, or f of g, f minus g, f times g. First, you find the domains of each of the functions. Once you find that, then the domain of the smallest one will be the domain of your answer. So what's the domain of this first function? In other words, what restrictions are there on x? Can x be negative? Yeah, you can put negative in there and square it, it becomes positive. Can x be 0? 0 squared is 0. That works. Can x be positive? Yes. So we have negative infinity to positive infinity, all real numbers. Again, memorize that library function chart. If you know what the graph looks like for x squared, then you know what the domain is. How about x plus 2? What's the domain of that one? What's that? What does the graph look like? Not for this one. Not this one. This is a linear equation because x doesn't have anything around it. This is what we did in chapter 1. The slope is 1. So this one, if you graphed it, it crosses through 2 and it goes like this. So it's negative infinity, positive infinity. The x squared function looks like this. X goes on forever and ever both ways. So since the domain of both of these equations is from negative infinity to positive infinity, the domain of this one is negative infinity to positive infinity. The domain of this one is negative infinity to positive infinity. The domain of that one is negative infinity to positive infinity. So what's the domain of this one? See, these other ones are okay because we can multiply, add, subtract all we want. This one, what can you not have on the bottom? You can have a 0. And we found out that we cannot have a -2 on the bottom. So our domain is from negative infinity to -2, and then from -2 to positive infinity. We just cannot use -2. How about the one we had earlier? What was that? X plus 1 square root of x plus 3. What's the domain of the first function? Yeah, because it's linear, it's negative infinity to positive infinity. Now, how about the second one? What's the smallest number you could have inside here? Remember, the graph we looked at originally looked like this. The smallest number you can have inside there is 0. So take this number, x plus 3, and set it equal to 0. And solve for x. So our graph, our equation here, can start at -3 and go to infinity. Because if we put -3 in there, -3 plus 3 is 0. And that's what, and we can have 0 in there. If we put -2 plus 3, it's +1, so we're okay. So whatever you have inside here, just set it equal to 0, and that'll tell you where you start. So since this is a more restrictive domain, that means the domain of this function is -3 to infinity. the domain of this function is -3 to infinity. Of that function is -3 to infinity. Okay, we know the domain's that, but is there any restrictions, any numbers we cannot use? Remember, we cannot have 0 on the bottom. What would x have to be to make it 0 on the bottom? So we cannot use -3. So it means our domain here, since we cannot use -3, is that. Since we cannot equal to -3 because of the bottom. Yes. Because these, it wouldn't matter. If I'm adding two numbers, there's no violation. But the smallest I could put inside this equation here is -3. So the smallest x I can use for any of these two combinations is -3. So again, whenever you have a composite function or adding, subtracting, multiplying, dividing functions, you always use the domain of the smaller function. Make sense? So again, you're only restricted by the restriction of the smallest one. All right. Now, the difference quotient. What does difference mean? Add, subtract, multiply, or divide. What does difference mean? Subtract. So this is a subtraction problem. What is quotient? Division, yeah. It's a fraction. What this does, it looks at the slope, but a new slope. Slope of a point on a curve. The difference quotient is used to find the slope of a point on a curve. In chapter 1, we learned the slope is this equation. And this only works for the slope between 2 points on a line. This is x1, y1, x2, y2. But this wouldn't work on a curve. Does that slope tell me the slope of that curve? No, because it crosses at 2 points. A line that crosses a curve at 2 points is called a secant line. So in other words, what we need is we cannot have 2 points. To find the slope of a curve, we cannot have 2 separate points. We can only use 1 point. For example, at this point here, the slope of the curve at that point there is there. That's called the tangent line. A secant line crosses a curve at 2 points. A tangent line touches the curve at 1 and only 1 point. Again, the secant line crosses the curve at 2 points. The tangent line touches the curve at only 1 point. So which one would have a more accurate slope? The more accurate slope is the tangent line, because that only touches the point at 1. So if we know the slope of this curve, of this line, then we know the slope of that point right there, because it's touching the curve at that point. So how do we get to it? We have to go from 2 points, x1, x2, y1, y2, down to only 1 point, x1, y1. Let's see how this is done. The distance between x2 and x1 we call h. So if you started at x1, how would you get to x2? If you started here, how would you get to here? Well, add h to it. x1 plus h is equal to x2. So like for here, if this equaled 1 and this equaled 5, what is h? What do you have to add to 1 to get to 5? 4. Because if I started here and I moved 4 spaces further, I get to 5. So let's solve for h. What do we get? H equals x2 minus x1. In our equation for a slope, do we have x2 minus x1 anywhere? On the bottom. Because remember, we don't want to have 2 separate points. What we want to do is we want to move this point, we want to move this x value closer to this one. Because we only want the line touching at one place. So remember, this one is f of x1. This one is f of x2. But remember, f of x2 is x1 plus h. So what have I just done there? I've eliminated the x2. I don't need it anymore. I don't need to have x2 anywhere else because x2 is now replaced by x1 plus h. and x2 minus x1 is replaced by h. So y2 is f of x plus h minus f of x. I don't have to put the 1 in there because that's the only point we have. So there is our difference quotient right there. I just showed you where it came from. Now let's use it in an equation. Remember, it's the difference quotient. What does it find? What does it find? The slope. The difference quotient, because now I don't need to have two separate points. I can have any shaped curve I want. As long as you give me x1, the first point, I want to take the second point and make it move closer and closer and closer. In other words, I want this thing to go closer to 0. Because as soon as this distance, h, becomes 0, then x1 and x2 are the same point. Let's see how this works now. Find me the difference quotient of that function. F of x plus h minus f of x all over h. So here are the steps. The first thing you have to do, you have to find f of x plus h. How do you do that? By placing a plus h after each x in the function. So anywhere you see an x, put a plus h behind it. So there's our first x. So I've put a plus h behind it. There's a second x. I put a plus h behind it. Now, remember, since it's an equation, x plus h, I have to put it in parentheses. It's not 2x plus h, it's x plus h times 2, because this is x times 2. Plug into the equation, plug into the difference quotient equation. We have f of x plus h minus f of x over h. So what is f of x plus h? 2x plus h minus 3. That's the first part. It goes there. There's the minus. And then the f of x goes after the minus. I have to put it in parentheses because it's after a negative sign. So always put your f of x inside parentheses after the minus sign. And then simplify. In other words, let's get rid of the parentheses. 2 times x is 2x plus 2 times h is 2h minus 3. This negative changes the signs of everybody inside the second parenthesis, so it becomes minus 2x and a positive 3. Everything after the minus sign has to cancel. If it doesn't, you did something wrong. So after this minus sign, so the negative 2x cancels with the 2x. The positive 3 cancels with the negative 3. The h's cancel. So our slope is 2. How do I know that's right? Look at our first equation, our original equation. Y equals mx plus b. What's the slope of this equation? 2. And that's what we got. We got slope equals 2. So that's just a test we use to make sure we're doing it correctly. Let's make it a bigger equation now. F of x equals 2x squared minus x minus 3. Find the difference quotient. What's the first thing you have to find? F of x plus h, right? So anywhere you see an x, put a plus h behind it. There's an x plus h under the square. There's an x plus h. I gotta put in parentheses. That's the first hurdle, because that's where the first mess up. If you forget the parentheses here or here, your answer is gonna be wrong. Because this negative is in front of the x, so when I put the plus h, I have to put it in parentheses because that's one equation, one number. Second step. Put it in this equation. So this first part is 2x plus h squared minus x plus h minus 3. There's the minus sign. And whatever's behind it goes in parentheses. It's the f of x. 2x squared minus x minus 3.
H equals the whole equation that we have for H.
Yes, that's this whole big thing here. And that's so basically all you're doing is cut and pasting, really. Just cut and paste that in the first part, put a minus sign, and put the second one inside parentheses. And that makes the second hard part. The first part is make sure you put the x plus h in the right place in parentheses. Then second hard part is make sure you put it in the right order in the right format. And here in this case, the next hard part is this part. How would you do that? X plus h squared. You distribute the square? You can't. So what you have to do here first is x plus h squared is x plus h times x plus h. That's just what we're doing here. So x times x is x squared. X times h is xh. H times x is the same thing as x times h by commutativity. And then h times h is h squared. And since all the signs are plus, all the signs are plus. Combine like terms, xh plus xh is 2xh. So this whole thing goes in place of this after the 2. So we have 2x squared plus 2xh plus h squared. Yeah, that's all just from there. We have the minus x plus h minus 3 minus 2x squared minus x minus 3. Is everybody okay so far? Did I lose anybody? This one here? Because here you had you have 2x plus h squared. We did. We got rid of the square because what square means, if you have x squared, that means x times x. So if you have x plus h squared, that's x plus h times x plus h. So we have to FOIL these. Everything in the first parenthesis multiplies to everything in the second parenthesis. So x times x, x squared. X times h, xh. H times x. And then combine like terms. So that's how we got rid of it. That's what I'm saying. That's the next hard part because we have to do that. If it was a 3, we'd have to do it again. And that's painful. The hard part's finished. Now comes the easy parts. Get rid of the parentheses. Multiply by 2 each term inside the first one. 2x squared. Positive, positive is positive. 2 times 2 is 4xh. Positive, positive is positive. 2 times h squared is 2h squared. That's the first part. Now we have the minus sign. Negative times x is negative x. Negative times h is negative h. That's the second part. Then we have the minus 3. And there's that minus. It gets distributed. There's basically all this minus sign here does is change the sign of everybody inside the parenthesis. So from +2, it becomes -2x squared. From -x, it becomes a +x. From -3, it becomes a +3. Remember, everything after this negative sign has to cancel. So this -2x squared cancel the +2x squared. The +x, -x. The +3, -3. So all I have left is 4xh plus 2h squared minus h all over h. Notice on top, everybody has at least one h. So I factor out one h out of everybody. Since the middle one has two of them, I just took one of them out. An unwritten rule, because a lot of people forget this one at the very end. An unwritten rule that I like to use, whenever you they all have an H, right? So to tell you what goes inside here in the middle, we had this equation here. We took out an H. So divide each one of these by H, because we took it out. Whatever's left goes inside here. So the H's cancel here, so it's a 4x. One H cancels, so it's a 2H. And these cancel, so it's a 1. The H's cancel. So our slope but remember, as we said, when we look for the tangent line, our slope has to be, our distance has to be 0. So as h goes to 0, this middle term disappears. So the true equation of that point is that. As h goes to 0, this is our form. I don't know what your textbook uses as an answer. They're both right answers. But if they want you to keep the h's in, this is it. But if they want you to take it to 0, in other words, cancel all the h's out, anything has an h, cancel out, this is the right one. So in other words, I would use this equation, plug it into the, tell me what x you want, I'll tell you what the slope is at that point. All right, that's it for today. There is one more we're going to do when we come back next week. I'm going to give you this question using, so try to work on this one over the weekend. Find me the difference quotient of this one. It'll test your knowledge of the division. All right, everybody, have a great, safe weekend. I will see you next